All right, today I'm going to tell you a little story about how math placement changed at ECC and how we used the topic from this week, Chapter 10, hypothesis testing, to actually help us make a good decision here about how to place students. So, I was doing some research and interested how there are different variables that go into a student's success here at ECC. And at the time, we were placing students with an ACT score, or if you transfer in, or if you took our placement test. We were using the Compass placement test at the time. And I wondered if other variables, like how you did in high school, would be good predictors. So I collected a bunch of data, and we were looking in particular at intermediate algebra. And we knew historically that class had a 55% success rate. And I was interested in, what about the students who did well in high school? How did they do in this course that was developmental, pre-collegiate, one level below? And so we had 88 students in this particular cohort. I think it was a couple of years worth of recent high school graduates that I was looking at. And of those 88, 78% were successful. So that was, I think, almost 89%. And so the question is, well, how unusual is that? Like, is that, I mean, obviously that's higher than 55%, but could that happen randomly? I mean, is that something we could make a decision on? So think about what we learned in Chapter 8. We learned about the distribution of the sample proportion. So if certain conditions are met, in this case, if n times p times 1 minus p is at least 10, so we had a sample size of 88. Our p, what we assumed was our proportion of success, of succeeding in the course, was 0.55, 55%. So if we take n times p times 1 minus p, that ends up being, focus. So about 21.8. So we're good there. So the sample proportion should be normally distributed. If we calculate the standard deviation, square root of p times 1 minus p all over n, it's about 5%, 0.053. So we would expect to get 55%, right? 0.55 right in the middle. And then if we go a standard deviation out each way, that's kind of the distribution of the sample proportions we should expect from random samples of size 88. And then our sample of 88 students who did well in high school, and that was actually 3.5 or higher in high school, was actually way out here, right? Way out, 0.89. Really high, really unusual. If you find the probability of that using a normal calculator, it's less than 1 at 10,000. So the odds of that happening randomly, it's basically impossible. That's not a random difference. So those students clearly were more prepared. Their mathematics, their placement test scores were distributed the same as everyone else, but they had some different behaviors for whatever reason. You know, students who do well in high school do well in college. I mean, it's not a shocking thing. So what we did as a college, we actually took these results and we decided, you know what, let's reframe those students who did well in high school and placed one level below. Let's call them college ready. And then they didn't have to take that intermediate algebra course. And this is an example of hypothesis testing, where you have an assumption of what you think is true. In our case, we think the proportion that's successful is going to be 55%. We have this certain distribution that we can calculate based on our distribution of the sample mean or the sample proportion or other variables, other statistics as well. And then if we observe something very unusual, that says, hey, you know what, this population that we're looking at is probably not the same as the population that we were comparing it to. And that is hypothesis testing, and that is what Chapter 10 is all about. Man, this light is so bright, but otherwise it's dark in here if I don't have this light. But, whew, die in here. Oh, see, but then if I don't have that, then it's like, all you see is my bald head. That's no good.